Good morning, guys, or afternoon, whenever you're watching this video. In this video, I'd like to go ahead and wrap up this whole idea of hypothesis testing. We've talked about setting up our hypotheses. We've talked about making a decision. We've talked about the error we could have. We talked about writing a conclusion. And I just want to bring everything together and actually in this video show you where that p-value is coming from that's going to help me make that decision of whether I should reject H0 or not reject H0. So I've just got just a couple notes here, then I have 5 examples to get through, okay? And so whenever we're running the problem, we're going to see something called a level of significance, okay? Whenever I see this level of significance, that is talking about my probability of type 1 error, okay? And so suppose it has a 1% level of significance. That means that I'm just wanting to have a 1% chance of making type 1 error, which is going to be rejecting H0 when H0 is actually true, which is typically the more fatal of the 2 errors. Now, you don't have to worry about setting this up, okay? The statistician will set up what the level of significance should be. So your most basic ones are 1%, 5%. Every once in a while you'll see a 10%. Until this book came out, I never really saw 2%, but they use 2%. So we have several that we can use. We'll get through them in our examples today. Now, every once in a while, they don't give you a level of significance. And so what I would like to do is go to the common one. If they don't give me one, the common level of significance that you want to use is 5%, okay? Now, you're going to see me I'm going to be working these problems pretty long. I'm going to make it so you can see everything on there. And it's a lot harder to make a mistake if you're drawing your picture, okay? If you're putting the p-value in the area, and whether you know if it's going to be a left tail test, right tail test, or split evenly between the 2 tails, okay? And that's going to give us some different types of tests that we want to look at, all of which we'll talk about in this video. And how I'm going to figure out which one it is, whether it's a left tail test, right tail test, or split evenly, is it's going to come from the alternative hypothesis. If you've done all your homework, and you've done your practice problems, and you've watched these videos, you should have some pretty good idea of how to set up your null hypothesis and your alternative hypothesis. So I don't think that's going to be a problem for us. Okay? So let's talk about the new part of this. I just want to try to draw pictures and determine what type of test I have. So for instance, on this one, it says that my null hypothesis is that mu is equal to 10, and my alternative hypothesis is mu is less than 10. Okay, so whenever I draw this, I'm just going to draw my nice bell-shaped curve. We should be getting good at these by now. And so I'm used to having 10 right here in the middle. I want to know the probability that I go less than 10. Well, less than 10 is on this side of my curve. And it tells me what my p-value is, 0.0935. And that's exactly how much of this tail I want to shade, is this 0.0935. That's my p-value. So I shaded about 9% of the area underneath this curve all the way down in the left tail. And so that answers what type of test I have. I have a left tail test. Okay. And that's all it would be looking for on that. I can definitely see myself asking this on your upcoming assessment. Hey, just draw me a picture and tell me what's going on here, okay? I think this is important to see. You guys try this one. And then come back and you can look at my picture. So go ahead and hit pause, and then I'll put mine up here as well. Hopefully you got something similar to this. Don't let this H0 right here throw you off, all right? I'm getting what type of test I need from my alternative hypothesis. All right, one more. We'll do this one together. this time, I'm not sure if I want to go less than or greater than on this one. Okay, so whenever I draw this, I got my 1/2 in the middle. We're going to come back and look at one similar to this. P-value's kind of similar to it as well. And so what has to happen on this is I don't know which tail I want to be in. I just know I want to be away from this 0.5. So in this case, I could be way down here in this tail, or I could be way down here in this tail. And what happens is the p-value is going to split evenly between these two tails. And so if I take the 0.2546 and divide it by 2, I've got 0.1273 of this left tail shaded and 0.1273 of this right tail shaded. And so it's kind of harder to reject the null hypothesis on this one because I'm taking my p-value and I'm making it so I have to be further away from this middle line right here. But that's the way it's going to work if I have we've got to name the test. This is a 2-tail test. A 2-tail test. And so, because I am shading in both tails on this. Awesome. And so after I set up my null and alternative hypothesis, this is going to be one of the first things that you see me do. Okay? So let's jump into a full example right here and try to fit everything out on this. I'll try to work it around my words here, so hopefully you have enough room to make this look better than what I am about to do on the screen. But it says I have some statistics students believe that the mean score on the first stats test is 65. Oh my goodness. I hope that it wasn't out of 100. That means that stats teacher is harder than yours. That's hard to believe, but maybe it's just out of I don't know, look at the score, 75 or 70 or something. So the instructor thinks the mean score is going to be higher than 65. That's going to help me a lot right there. Okay, so he takes 10 of the stats students. I don't know why he didn't take them all. Maybe he has a really, really large class. Maybe it's at Ohio State or something. And he gets these 10 scores, and he performs a hypothesis test at the 5% level of significance. Ooh, that's good right there, knowing that that's my alpha level. Okay, the data are assumed to be a normal distribution. Determine what type of test it is, set up the hypothesis, p-value, sketch a graph, state your conclusion. Those are all things I'm going to be looking for on this. So I'm going to go ahead and set up my hypothesis test first. So I've got my H0. I got my alternative hypothesis. And so the first thing you got to look at is, am I dealing with the population proportion or the population mean? Well, look at these scores right here. These aren't proportions right there. Those are they're means. The mean score, there it says the word mean right there. So status quo says that my mean score was 65. That's what all the students said. And what the statistician, the teacher, the researcher is wanting to prove is that the mean score was actually higher than 65. Boom, I've got my hypothesis test. We can mark that up. Set up the hypothesis test. Now, I would say from here, go ahead and sketch your graph. So I'm not even doing stuff close to the order. I could, I guess, but I'm going to have 65 right here in the middle. And what I'm hoping to do is get something so far over here in this tail that I get to reject H0. That's what the professor instructor is trying to show. Okay, so I'm way over here to the right because I know that it's greater than. So I'm dealing with a right tail test. I have named my test. What type of test? Got it. Okay, and I sketched my graph. Man, we are mowing through these. Next up, I want to find the p-value. Okay, now this is going to take a little bit of work on this. So if you're using the graphing calculator, there is an easier way to do this in the graphing calculator. If you have your iPhone on you and you downloaded the Graphing Calculator app that we talked about, unfortunately is in the paid portion of it, so you can fork up the $5 and be able to work this a little bit easier. But I'll just let you play with that if you want to. I'm going to show you, at least this year, the way that I think a lot of you are going to have to work it using the table. Okay? And so remember that whenever we are dealing with Muse, that we have to use a t-test. It follows a student's t-distribution. So what I want to do is I want to find my t-score. Okay? And my t-score is going to be whatever my average is. Ooh, I haven't averaged all these numbers. So I need to average. Oh, my shadow's in the way. You guys can't see that. I need to average all those numbers. And sure enough, I got the average to be a 67 on that. Okay? So that was my average. Now, is that far enough away? I mean, what if I would have sampled another 10 and I would have got a 63 and I wasn't higher than that? Well, my standard deviation is going to help me out with that. So in my graphing calculator, I found that my standard deviation, whenever I ran these 10 numbers, let me kind of write out what I found here. I found that my mu sub x bar was, what did I say, 67? And then my standard deviation, sorry about that. And then I found my sample. Standard deviation to be 3 point. How many decimals do I want to keep? I'll just keep 4. 3.1972. Okay. And so I need to put in that value, this 3.1972, and then I need to let it know that I did 10 in my sample. Okay, so if I divide that by square root of 10, that lets it know that my sample size was 10. And that's going to give me my test statistic. My test statistic is 1.98. Okay, so I want to go back to my t-table. Kind of finally figured out that I can just do this. And my test statistic of 1.98, I want to try to find that on here. Remember, this t-table is a little bit different. I got my degrees of freedom running down this left side right here. Oops. Running down my left side. And I got my areas, my probabilities running across the top right here. So I need to find 1.98 or something close to 1.98. I guess that means what? Oh, and for my degrees of freedom to be 9. There we go. So if I run across this column right here, 1.98 lands right between these two numbers. Mark them off. And that is between 5% and 0.025%. And so using it this way, I'm not really able to get my hands on exactly what the p-value is, but coming back to my example, I know that my p-value is between, what I say, 0.05 and 0.025. That's a low p-value right there, okay? So if I was to actually run this in my calculator, I would get this p-value right here to be 0.0315. So you'll have to tell me whether or not you're running this in a calculator or on the table, okay, whenever you're taking your test. But this is definitely below my level of significance right here. So my decision on this is going to be to reject H0. We've already talked about rejecting H0 before. And again, it's just because my p-value was less than this 5%, which is what the statistician said would be significant. Anything, if I would have something over 5%, then I would not reject H0. Now remember, we need the sentence that explains it to either your mom or my mom as to what's going on. So I can say, there is sufficient evidence. Sufficient evidence to conclude that, keep it easy, the mean score was higher than 65. Don't know what it was, but my students are more than likely incorrect. If I was to sample 10 more students, I only have like a 3% chance at getting something more extreme than what I got whenever I surveyed these 10 students. And so, yeah, I don't know if the mean score is going to be 67, but I am fairly confident that it's going to be more than 65. So don't say that it's 67 or anything. That's just what it was with these 10 students. Chances are my students are undercutting me a little bit and saying the test was too hard, saying that it was only 65. All right. Now that's a lot. There's a lot going on there. A couple of new things, but it's not too bad. All right. So I want to go ahead. I'm going to work this next example with you again. We're going to do all this again. So if you're scratching your head about some of it, either hit rewind on it and go back and watch more of it. Watch that last problem again, or you can just kind of go with us through this one. There's a student group on campus, on a college campus, claims that freshman students study at least 2.5 hours a day on average. Well, there's a stats class that's skeptical, and so they took a random sample of 30 freshmen and found that the mean study time is 137 minutes with a standard deviation of 45 minutes. Ooh, they've done some calculator work for me already. I appreciate that. Is the student academic group's claim correct? Now, this one didn't take you step by step through. So if you want to go back and look at everything that we did on the last one, I'm going to be checking that on all your hypothesis tests. I want to see, first up, I want to see your H naught and your HA. So, right now, the student academic group freshmen, they study at least 2.5 hours a day. 2.5 hours. I'm just going to switch everything to minutes because whenever the stats class did everything later, they did everything in minutes. So 2.5 hours. Well, 120 minutes is 2 hours. Add 30 to that, 150. So they're saying that my mu should be 150, or at least 150 is what it says. So less than or equal to. Put the or equal to on your knot. So this guy should always have an equal on it somewhere. And so my alternative, they're saying, you know what, we're pretty skeptical. I think the opposite is true. I don't think freshmen study that much. They're too busy hanging out with friends, going to football games, doing stuff that the normal college freshman does, whatever that may be. Some of you will find out in a few months. And so they don't know if it's 137, but they just think that it's less than 150, that this status quo of 150 is kind of an overshot there. All right, so let me draw a picture as to what's going on here. So we have 150 right here in the middle, and this student group, it found something over here. It found 137. Question is that red line far enough over in the tail that we can reject H naught? Let's find out. So I've got my T equals, I guess I wondered what type of test this is. We have a left tail test. I think that was a question on the final last year. They set up a picture like that, and they said, what type of test is it? Not many people missed it. And so they've done the work for me. They got my 137. My mu was 150. And then my standard deviation was 45 minutes. But I need to take into account that I did 30 freshmen. And again, I'm just doing my standard deviation for X bar, which is going to be just the standard deviation they gave me over the square root of my n. Okay, and so that's where that's coming from. Let me make that an s. So that's all I'm doing when I plug this into the bottom down here. And so whenever I ran this test statistic, I've got negative 1.58. Okay, that doesn't really help me know how far over in the tail I am, but I can definitely find that and figure out where I'm at. So I'm going to go back to my t-chart up here. Erase all this. What was my degrees of freedom? Degrees of freedom should be 29. So, barely less than that. I'm down here to 29, and I'm looking for 1.58. 1.58, well, it's going to be somewhere between these two values, right? Because I just have an increasing values right there, which is somewhere between 10 and 5%. So that means my p-value is between 10% and 5%. Not equal to, but between 10% and 5%. If you plug this into your calculator, you actually get that this area right here is 0.0625. So I don't have to have this year since we're just going straight to the table. If I know it's between 5 and 10%, and I've set my level of significance at 1%, that means I want my p-value to be less than this 1% right here. Now, I did not get that. It is at 6%, or anything between 5 and 10% is going to be bigger than 1%. So it's way too big. So I don't get to reject H0. No, I didn't say accept. Do not reject H0. Some people will say retain H0. That's perfectly fine too. Just don't say accept. All right, we're not accepting it. We just didn't get the evidence we needed on this trial right here. And so I need a sentence again. So we say there is insufficient evidence to conclude whatever my H0 is. The mean study time for freshmen is less than 2.5 hours. Okay. I've worded it very similar. Whether I reject H0 or do not reject H0, it's either there is sufficient evidence or there is insufficient evidence to conclude whatever your H sub A is. You just have to restate it. Okay. All right, I'll do one more just so you can have a good solid example on it, and then I'm going to let you try one on your own. And you'll have more in the practice problems to get good at this. Okay? So example 4, June believes that 50% of first-time brides in the United States are younger than their grooms. So she performs a hypothesis to determine if the percentage is the same or different than 50%. So June on this one isn't sure if she's wanting to go above 50% or less than 50%. So she takes 100 first-time brides. That's going to be helpful right here. And 53 of them reply that they are younger than their grooms. Not that far away for 100. I'm just going to tell you that right now. And so she's wanting to use a 1% level of significance. That's important. Determine what type of test this is, hypothesis, p-values, sketch graph, everything that we've done. I'm not going to change this list of things I want, whether I include it or not. I want you running everything. I want to see your entire test, whether it has all these things listed out or whether it just says, hey, figure it out on your own. Now, this is where I turn around and normally ask you guys, hey, what's going to be different about this one? But there's no one sitting here in the room. So hopefully you've already picked up on what's different on this one. is the fact that I am dealing with a proportion on this one. Okay? And so the status quo says that 50% of the time the groom is older, 50% of the time the bride is older. And what June is wanting to show is, well, that's just not true. It's just not equal to 50%. I'm not sure which way it is, but it just doesn't make sense for it to be 50%. Okay, so got a little, or let's go ahead and draw our curve in our test. So should be right here at 50%. I'm hoping to get something down here far enough in either tail on this. So if I'm dealing with the P, the population proportion P up there, remember I got to switch back to a Z-score. Probably see that up there in my top tabs where I got my Z chart ready to go. Okay, now she got 53% minus the 50% she should have got over, well, I need my standard deviation. They didn't tell me what my standard deviation is. Remember, the standard deviation on this for a P is going to be my P hat times 1 minus P hat over N, square root of all that. Sorry about that. My sigma is going to be the square root of P times 1 minus P over my N, the number of people I have. So I'm wanting to use this 50% right here because this guy right here was just my sample on it. So it's going to change from sample to sample. I want to use the one that's going to stay concrete. So I have 0.5 times 0.5 over 100. Okay? And I just did this little song and dance in my calculator, and I got 0.6. Now remember, Z-score, I'm going to be able to figure out what the p-value is exactly. It's going to be really cool. Okay, so if I find the p-value, or the probability at 0.6, okay, I'm going to go back to my Z-chart. Z-chart, my p-score was 0.6 exactly. I get, let's talk about this real quick. You're probably looking right here saying, why isn't he just using 0.7257? I can use that. Or I can come over here and use negative 0.6 and get 0.2743. Either one. Okay. I want to show you why this one makes a little bit more sense. 0.2743, 0.7257. 0.2743 is actually going to be this area right here. 0.2743. Whereas the 0.7257, remember, that's going to be all of this area going over that I'm not really interested in. So I like those negative values a little bit better. Now, I definitely could do 1 minus that point, whatever I found. But the idea is if this is 0.2743, this one over here is 0.2743. Okay? Making it so that my p-value is going to be both of these combined, both of these added together. So I take the 0.2743, multiply it by 2, 0.5486. That's my p-value. That is a large p-value. Like I said at the beginning, for 100 people, just getting 53, that's not that far away from 50. And so we're not going to be in very good shape right there. So unfortunately, June, we are not rejecting H naught. Okay. So we can say there is, again, insufficient evidence struggling here. Let's just start this over. Ooh. There is insufficient evidence to conclude what? That the proportion of, let's see, at the proportion, we can just say the proportion of, let's see, of brides younger than grooms. There it is. Is not 50%. Awesome. And that explains it well. Okay, I want that sentence at the end. State your conclusion is going to be whether you reject or don't reject in a sentence that describes it to your mom. All right, this time you're on your own. I'm going to let you have at this one, and then I will put all my work up here, and then you can see if you get a similar answer to me. It doesn't have to be exactly mine. Your wording might be off. You know, whether you're using a calculator or not, that might throw us off. But should get something close. So go ahead and hit pause. I got to reject H naught on this one. Okay. A couple things that I want to talk to you about. I forgot to mention what the type of test it was on example 4. It was a two-tailed test, and it's just always easier if when you're looking for these p-values on the z-table, if you always use the negative. Okay, I know in the last one I had the two-tailed test. I used a negative. That negative will always tell me exactly what this area is, and since it's symmetric, even if I'm looking for something that's over here in the right tail, which I'm not on this one, I can go ahead and reflect it over and use the negative, and I don't have to worry about doing 1 minus whatever that probability is. Okay, so I don't have to worry about that at all. A little bit of a shortcut there. Again, all this can be done in the calculator. If you're interested in that, have it ready for me during the Q&A, or you can just click on the, you can look in the book on the link that I give you, and it gives you step-by-step instructions how to do it in there as well. Okay. Awesome. Well, we have an example 6. I wasn't aware of that. We're going to skip example 6 for now, and let's go straight to the practice problems.